In this video, we'll talk about parent functions and transformations. So let's start by talking about what a parent function is. So a parent function in mathematics, they're kind of using this to describe a family of functions, so ones that have similar qualities. The first classic one is y equals x. And this is your family of lines. It goes to the origin. Basically, all lines are some alteration of this y equals x line. Whether you make it steeper, whether you move it up, whether you do some combination of the two, this is the base function for all lines. Taking it up a step further, you've got y equals x squared, which is your classic parabola. So it comes down through the origin and then peaks back up. So the idea is all other parabolas, theoretically, we can move around, adjust, make steeper, make wider, whatever it is. That's one, or I guess two examples of parent functions for starters. So let's keep going with this idea. The next kind of classic example would be a cubic function, which has that radial symmetry, goes through the origin and peaks through. And we can keep going with these powers. Each power kind of has a slightly different function. However, most of what we know cubics behave a lot like quintics, so we can make some comparisons there. But this is just giving you an idea of what a parent function is. So some ones that are not necessarily polynomial or power functions would be, well, a square root function. So y equals the square root of x, and that one looks kind of like this. And we know that all square root functions kind of have that overall shape. They might be flipped, they might be a little bit squished, they might be stretched, they might be shifted, but that's the idea, is they kind of have this lazy arc shape. And then we have a reciprocal function, which is y equals 1 over x. And that's kind of our classic asymptotic example when we're talking about a rational function. If we're talking about 1 over x squared, this idea that it will have a couple of pieces, there will be a break in it, maybe two, and there's a lot that we can determine with just these handful of parent functions. There are more, but just to give you an idea of some. So overall, with transformations, we can essentially kind of write our equation in what they call vertex format, or at least for quadratics they do. So all of these letters here have meaning. They have an effect somehow. And we'll be comparing this function that we're going to make to its parent function. And that's what this R does. This is going to tell you what kind of family you're in. So if it's a 3, you're talking about a cubic. If it's a 2, you're talking about a quadratic. If it's a half, you're talking about a square root function. If it's -1, you're talking about a reciprocal. So this is going to tell you what family you're in. So basically comparing to the parent function. If we look at M, this is kind of your steepness, for lack of a better term. And if M is greater than 1, it's going to get steeper. If it's fractional, it's going to get more gradual. If it's negative, it's going to flip over the axis. So there's a lot going on there. So positive and greater than 1, well, it'll get a lot steeper. If it's negative, it's going to flip. If you think about like negative slope, that's kind of what happens. Everything's going to turn negative. And then if it's fractional, it's going to get more gradual. If you think about half x squared, how that applies to 1x squared, well, it's going to be much more gradual. Okay, now let's take a look at P. I'm going to skip over N for a second. P is pretty easy to visualize. That's your vertical shift. So that's how much it goes up and down, and that one behaves exactly like you would think. Positive is going to move it up. and negative is going to move it down. And then N. This is your horizontal shift, meaning it moves left or right. And this one is backwards. It's it's counterintuitive. Negative is going to move it right, and positive is going to move it left. Left. So this might look a little strange. We're going to do an example to kind of put it into context. But before we do, I just want to make a quick note here about this R. A lot of functions, especially the ones we've just talked about, we can write with that power. So like square root of x, that equals x to the 1/2 power. And if we're looking at 1 over x, well, that's x to the -1 power. You can still use R to kind of classify what family you're in, and all the other thoughts still apply. So let's take a look at an example. We're trying to describe the shift from this function, 3 times x plus 1 cubed minus 7, and we're comparing it to its original parent function, y equals x cubed. Now this is more useful than trying to actually graph it, because this way we can use our graphing software and we can think, okay, this thing should be left so much, down so much, then it should be a little steeper, and we can use this as a way to kind of double check and make sure that when we do graph it, it does make sense. So I'm looking at this. There's the 3 right out front. So I can say, okay, it's steepened by a factor of 3. And that might not sound too terribly scientific or accurate, but the idea is, okay, it's going to be a little steeper, or quite a bit steeper, I guess, in this case. And then I'm looking at the -7. This is telling me it's shifted down 7 units. And I'm going to look at the 1. This is telling me it's shifted left by 1 unit. And this is it. That is the description. Now we could potentially do even a sketch of our graph. So if we have our axis, we draw x cubed, what we should be looking at is, okay, it's going to be steeper, it's down 7 units, and it's left 1 unit. So let's go down 7 and left 1. We know it's going to go through that point kind of like this one does. And then it's going to be steeper. So we should expect to see something like that. So very, very steep. And that would just be a rough sketch of the graph. So we can use this to make a graph. Usually you'll use it to kind of just have an idea of an explanation of what it's going to look like. So this is usually what you're going to do with it. However, sometimes being able to make a quick sketch, very helpful.